This video is about a review for sine and cosine law, part 2. Number 1. The diagram shows a circle of radius 8 meters. The points A, B, C, D lies on the circumference of the circle. BC equals 14 meters. CD equals 11.5 meters. AD equals 8 meters. Angle BCD equals 73 degree. Angle ADC equals 104 degree. First of all, you need to label on this diagram about given information. So we got BC is 14. CD equals 11.5. AD equals 8. Angle BCD, that's a 73 degree. Angle ADC equals 104 degree. For A, find AC. In triangle ADC, we are given SAS pattern. We're looking for remaining side. We got to use a cosine law. Therefore, for AC square equals 8 square plus 11.5 square minus 2 times 8 times 11.5 cosine 104 degree. When you put this into calculator, make sure the mode you have to put into degree. After you get the AC square, then we got to do square root both sides. We got AC equals 15.517 meters. So we label AC on the diagram 15.517. For B, find angle ACD. This angle, we assume angle ACD equals alpha. In triangle ADC, you can use a cosine law to figure out this angle, or you can use a sine law. But generally speaking, sine law is much easier than cosine law. Therefore, I use a sine law to figure out this angle ACD. We do 8 over sine alpha equals 15.517 over sine 104 degree. Cross multiply. That's sine alpha equals denominator, that's 15.517. 8 times sine 104 degree. So we put into calculator, we will get the alpha doing inverse sine of 0.500. That's 30 degree. So we label here it's 30 degree. And we know this will be 43 degree. Therefore, angle ACB equals 73 degree minus 30 degree. We got 43 degree. For C, find the area of triangle ADC. Remember, we need 1/2 AB sine C. We need a SAS pattern for triangle ADC. We got here's a SAS. Therefore, area for triangle ADC equals 1/2 times 8 times 11.5 times sine 104 degree. Put into calculator, we get 44.634 meters square. That's the area for triangle ADC. Let's go to D. Find the shaded area. First of all, we need to get the area for triangle ABC. We need a SAS pattern. That's SAS pattern. So we got the 1/2 times 14 times 15.517 times sine 43 degree. We put into calculator, we got 74.078 meters square. That's the area for triangle ABC. Shaded area equals circle, that's pi r square. Radius is a square minus area of triangle ADC, that's 44.634. Then you minus 74.078. We will get 82.350 meters square. That's the shaded area. Number 2, consider a circle with a center O and a radian 7. Triangle ABC is drawn such that its vertices are on the circumference of the circle. AB equals 12.2 centimeters, BC equals 10.4 centimeters, and angle ACB equals 1.058 radian. Find angle BAC, this angle. According to the problem, what's given? Side angle. We're looking for angle. Therefore, we got to use sine law. 12.2 over sine 1.058 equals 10.4 over sine angle BAC. So we do cross multiply. Sine angle BAC equals, this number go to denominator, 12.2. Top will be 10.4 times sine 1.058. You put this into calculator, you will get. Make sure the mode, you need to go back to radian this time. We got 0.743. So angle BAC equals inverse sine of 0.743. That is 0.837. For this problem, you cannot get obtuse angle. The reason is 10.4 is less than 12.2. So this angle must be less than 1.058. Let's label this angle 0.837. Therefore, we can figure out this angle. Since for this problem, we are using radian. In a triangle, altogether, sum of all angle equals pi. So we use pi minus 1.058. Also minus 0.837. You will get, we got angle B equals 1.247. Therefore, If we want to look for AC, we have pattern SAS. We can use the cosine law this time. We got AC squared equals 12.2 squared plus 10.4 squared minus 2 times 12.2 times 10.4 cosine 1.247. When you put into calculator, make sure mode is in radian. Then we got to do square root of both sides. We got AC equals 13.276. Label 13.276. Now let's look at C. Find the arc length of ABC. We know arc length equals theta times radians. We need to figure out the central angle. Therefore, I connect OA and OC. This will be theta. If we want to figure out this theta, we can get this angle first. This angle let's label as alpha. Alpha is a central angle, and B is an inscribed angle. Alpha equals 2 times angle B, which means 2 times 1.247 equals. We got alpha equals 1.494. For theta equals. This is a circle. For circle, that's 2 pi minus alpha. Means 2 pi minus 2.494. We got theta equals 3.789. Therefore, for the arc length ABC, you will get theta times radians. Radians given 7. Therefore, we got 3.789 times 7. We got, so arc length equals 26.523 centimeters. For number 3, the following diagram shows 3 towns A, B, and C. Town B is 5 kilometers from town A on a bearing 70 degree. Town C is 8 kilometers from town B on a bearing of 115 degree. Find angle ABC. First of all, we can figure out this angle. That is 180 degree minus 70 degree equals 110 degree. Then for angle ABC equals 360 degree minus 115 degree minus 110. The reason for this angle is 110 degree because these two, they are parallel line. And these two angles, they are consecutive interior angles, which means the sum of these two angles equals 180 degree. we got angle ABC equals 135 degree. For B, find the distance from tongue A to tongue C. We need to connect A and C. For triangle ABC, if we're looking for AC, we are given SA as a pattern. Therefore, we got to use cosine law. AC squared equals 5 squared plus 8 squared minus 2 times 5 times 8 cosine 135 degree. After you got the answer for AC squared, you got to do square root both sides. Got AC equals 12.065 kilometer will be the answer for AC. So we label that is 12.065. This is 135 degree for angle B. For C, use the sine rule to find angle ACB. Use the sine rule, we got 5 over sine angle ACB equals 12.065 over sine 135. Cross multiply. We got sine angle ACB equals, denominator will be 12.065. Numerator 5 times sine 135 degree. Put into calculator, we will get. We got 0.293 for sine angle ACB. Therefore, angle ACB equals inverse sine of 0.293. We got 17 degree. For number 4, a shape is sailing north from a point A towards point D. Point C is 175 kilometers north of A. Point D is 60 kilometers north of C. There is an island at E. The bearing of E from A is 55 degree. The bearing of E from C is 134 degree. For A, find the bearing of A from E. From E, which means we need to draw this vertical line pointing to the north. The bearing angle will be this one. First of all, I will extend this line. From here to here, that's 180 degree. 180 at this angle will be this bearing of A from E. Since these two lines, they are parallel, therefore, these two angles must be equal to each other because they are alternate interior angles. Therefore, for A, bearing of A from E will be 55 degree plus 180 degree. That is 235 degree. For B, find CE. We're working on triangle AEC. Try to figure out all angle available. This angle, you can use 180 degree minus 134. That's 46 degree. This angle, you can use 180 minus this to get this angle. or you can use 134 degree minus 55 degree. That's 79 degree. Because 134 degree is the exterior angle of this triangle, which means 134 equals the sum of non-adjacent interior angles of this triangle. For this diagram, angle 1 is the exterior angle of this triangle. Number 2 and 3 we call non-adjacent interior angle. Angle 1 equals angle 2 plus angle 3. This is a very important fact for exterior angle of a triangle. Since for this triangle AEC, we got two angles, we can use sine law. CE over sine 55 degree equals 175 over sine 79 degree. Cross multiply. CE equals denominator, that's sine 79 degree. Numerator will be 175 times sine 55 degree. Put into calculator, we will get 146.035 kilometers. For C, find the DE. We label CE, that is 146.035 kilometers. We want to find the DE. We connect DE first. In triangle CDE, we are given SAS. We're looking for remaining sides. Therefore, we got to use the cosine law. We got the DE squared equals 60 squared plus 146.035 squared minus 2 times 60 times 146.035 times cosine 134 degree. After you get the DE squared, you got to do square root of both sides. Then we got the DE equals 192.612 kilometers.